Hi everyone, today I'm teaching how to solve the problem round robin scheduling. Our question is quantum which is 5. First we need to draw a Gantt chart. The Gantt chart shapes something like a rectangle shape. First we take a look for the arrival time, which is the earliest time that arrive, which is the process is P5. The arrival time which is 0. And then because the quantum is 5, so we draw a line and then stop at 5. Until here we need to provide a small table. For the small table included for the process and burst time. We put P5 into a small table and then the burst time which is 6. And then we take a look for the duration 0 until 5. See whether got process coming or not. In this question we got 3 process coming, which is P6, P4 and P3. And then we choose the P6 which is arrival time 2 and the burst time is 8. And then the P3 arrival time is 4. Because the P3 and P4 arrival time is same, so we compare to the burst time. We choose the P4 first, which is burst time is 5. And then we continue to the process P3, which is burst time is 6. We go up again, because the duration is 0 until 5, so we need in the small table we need to minus 5 equal to 1, and then we cancel it out, bring the P5 to bottom and the burst time left 1. We continue to the process which is P6, same again because the quantum is 5, so we 5 plus 5 which is 10. And see between the duration 5 to 10, see got process coming or not. In this question we got P1 and P2, which is the arrival time is 6 and 8. The P2 burst time is 5 and the P1 burst time is 9. Same again, we need to minus 5 again, and then 8 minus 5 equal to 3, and then cancel out. Bring the process P6 to the bottom and the burst left 3. Since we all process P1 until P6 is done, we just simply use this table. And then we continue for the process P4, which is the burst time is 5. So the burst time is same with the quantum. We just simply plus 5, which is 10 plus 5, which is 15. And then here minus 5 again, which is 0. And then the P4 is done. And then the P3 is 6. And then we put the P3 into a Gantt chart. Plus 5 again, which is 20. And here minus 5, which is 1. Because the space not enough, so I just simply continue another side with P3 left 1 burst time. We continue for the P5 and the burst time is 1. If the burst time is lower than the quantum, we just simply pass the burst time. So it's 20 plus 1, which is 21, and 1 minus 1 equal to 0. The P5 is done. And we proceed to the P2. The P2 which is burst time is 5. 21 plus 5 which is 26 and minus 5 again equal to 0, and the P2 done also. And we proceed to the P1. The quantum is 5, so we 26 plus 5 which is 31. And here we need to minus 5 again, which is left 4 equal to 4, and then cancel out, bring to the bottom, which is P1 burst time equal to 4. Now we proceed to the P6. The P6 burst time which is 3, so we need to set 31 plus 3 which is 34, and 3 minus 3 equal to 0. The process P6 is done, and we proceed to the P3. The burst time is 1, so up to that 34 plus 1 which is 35, and P3 That also, and the last process, which is P1, the first time left 4, we need to get 35 plus 4, which is 39, and 4 minus 4 equal to 0, the P1 done also. The formula for waiting time, which is starting time minus arrival time. You need to remember it. Since we got 6 process, P1 until P6. Because in the Gantt chart, P1 is separately, so we need 2 separately and then sum up. We choose the in front one. P1 26 which is the starting time and minus the arrival time. The P1 arrival time, which is at, and then 26 minus s, which is equal to 18 plus, once we done, take that P1. Because it's separate, so we need to take the earliest one in front, 35 minus the 31. So mean we need to get 35 minus 31 equal to 4, 18 plus 4 equal to 22. And we proceed to the P2. P2, the starting time is 21, and then minus the arrival time, which is 6, equal to 15. Take that, and we proceed to the P3. Same also, it's separate, so we need to do separately, which is 15, the starting time minus the arrival time, which is 4, equal to 11, plus the another P3 process, 34, minus the 20, equal to 14, and 11 plus 14 equal to 25. Now we proceed to the P4. The starting time is 10 minus the arrival time, which is 4, equal to 6. And we proceed to the P5, 0 minus the arrival time equal to 0 plus another process, which is same also P5, 20 minus 5. 20 minus 5 equal to 15, 0, and then 0 plus 15, which is 15. And then we proceed to the last process, which is P6. The starting time is 2 minus the arrival time, which is 2, equal to 3, plus the last process, P6, 31 minus 10. 31 minus 10 equal to 21, and 3 plus 21 equal to 24. Now we proceed to the average waiting time. We need to combine all the waiting time and divided by how many process in the question. In this case, we got 6 process and also got 6 arrival times, which is 22 plus 15 plus 25 plus 6 plus 15 and plus 24. And divided by 6 process, which is 6, the final answer is 17.8 milliseconds.